This week I'm building the Analytical engine. I got to use a tool I've had for many years, but never actually plugged in, the Rotary table. The standard mill has 3 axes. You have X for moving left and right, you have Y for moving front and back, and Z for moving up and down. So when you have your piece on the table, you can move down, cut some pieces out, move back up again. But the problem is these figure wheels have numbers that go all the way around the outside. So your mill can't turn and get that way. So the rotary table sits on the mill, and this part spins. It doesn't spin fast like a lathe motor. It spins very slowly and accurately. So I'm going to put the figure wheel up against it, and then I can come down, and it will turn, so I can cut all the numbers. One interesting part about the CAM software is it shows the tool moving instead of the workpiece moving. So the engraving toolpath kind of looks like a cool sunburst. Most of the work in getting this thing running correctly was actually in programming. It was going from the CAM software to the mill control to get it to spin the right direction, to get it to not spin 360 when it only needed to turn 1 degree. And I only broke one tool while trying to fix that. The tool I usually use for engraving is this very fine ballpoint. But the numbers on the figure wheel are too close to this tall edge. So when it goes down, it's going to end up hitting those teeth. So instead, I have to use a diamond drag bit, which has a very small sharp diamond at the end, and this is on a spring. So instead of spinning and cutting, this just goes straight into the material and then drags across the surface, cutting a groove. With all those figure wheels now done, there's only a few more pieces that actually push the gears, make them move, and then it'll be on to the next section, which will hopefully go much faster since now I'm comfortable with milling aluminum, have a better idea of all the tolerances I need, and what design choices on this were bad ones to start with.